Exploited, the Cyber Truth, a podcast by RunSafe Security.
Welcome back, everybody, to Exploited, the Cyber Truth. I am Paul Ducklin. For this episode, I'm joined by Shane Fry, CTO at RunSafe Security. Hello, Shane.
Hello. Thanks for having me.
You've been on the podcast before, so this is your second time. Welcome back. And our special guest today is Andrew McPhee. And Andrew, you are the Solutions Manager for Industrial Security at a company that needs little introduction, I guess, namely Cisco. Welcome.
Thank you. Happy to be here.
Andrew, our title for this week is quite a broad one, so we might not get through all the questions that we've discussed in advance, but let's give it our best shot because it's not only a broad but also a deep and very important topic, and that is seeing the invisible, the reality of OT security. So why don't we kick off, Andrew, by you telling us how you got into cybersecurity in general, and perhaps more interestingly and importantly, how you got to focus on industrial control systems and OT.
Yeah, so I actually got into OT before I got into security. So my background or where I started, where I specialized in, I was a mechatronic engineer. That was my specialty. So I actually should have been an automation engineer. I did accept the role as an automation engineer. But coming out of university, I took a trip over to the US. I am Irish, and there was an intern position at a company called Cisco. I was like, sure, let's work for Cisco for a summer while I explore the US a little bit, and I kind of just went on board. So I'm on an 11-year internship, as I call it, as I've been here ever since.
Hardly started.
Yeah, exactly. I started off as a software engineer within our IoT business unit. So I used to work in our innovation labs, where we'd show you the art of the possible of what you could do in this IoT space when it was new and exciting. And coming from that OT background, I kind of just fell into things. So software engineer for IoT, we spun up an automotive business unit within Cisco where we focused on in-vehicle networking. And I took that software engineer kind of skill set over to there, worked on prototypes and the early builds of what we did there. And during that time, met a lot of very smart people, including folks who had been dealing their whole career in security, learned a lot from them. So when I was ready to move into big Cisco from all of the mini startups within it, I moved to the security business group. I worked as an architect on SASE architectures, breach defense, the firewall portfolio, anything that you could really touch. I wrote the Cisco Validate designs for that. And then full circle moment, our OT business group that focuses on this as their day job, I was kind of working in and out with them because of my background, and they needed a full-time OT specialist to work on security. So, started off OT, came to Cisco, learned security, on my way back to OT.
So there were several sort of orbits around the sun, if you like, during your career. Now, it sounds as though you're in the position that very many people who started out in OT probably are, in that when they started, cybersecurity maybe wasn't either their first, second, or even third interest, and perhaps wasn't as important or as significant as it is today. Would you agree with that?
For sure, yeah. I didn't know what a TCP or UDP packet was leaving university. It wasn't something that we focused on. We had no idea. We understood that we needed to connect PLCs together, but I would have been responsible for, daisy chaining PLCs together just like every other automation engineer is, because we didn't know any better. We weren't taught any better. So for sure, cybersecurity, networking in general wasn't part of the curriculum.
So security by design, as I guess we refer to it today, had a little bit of a back seat back then. Is that right?
Oh, yeah. It probably still does. If I went back and repeated my course today, I'm sure there's still no security modules built in. Security was one of those things that kind of happened and gained interest from just on-job experience when I was in the automotive business and seeing the rise of the autonomous vehicles and how those are being more and more interconnected, and the safety nature of doing that. That's what kind of spawned my interest, and all of those same principles apply to the manufacturing plants and substations and our intersections. It's when you put an interesting use case behind security, suddenly it starts to matter.
Yeah, especially when that use case is saving the business money because you don't have cyber outages in your manufacturing plants, right?
For sure. Yeah.
And I guess with increasing regulation and liability rules, particularly thinking there of the EU Cyber Resilience Act that says, you're not supposed to sweep things under the carpet. If you try from now on, we're going to deal with that by actually holding you liable. There'll be no sort of limitation of warranty or anything like that. That certainly focuses the mind from a financial point of view. But I guess we're all starting to feel the true physical dangers of some of this. There's a big difference between, hey, I couldn't use Zoom this morning and my meeting happened 30 minutes late. There's a big difference between that and, hey, the welding robot went crazy on the factory floor, isn't there?
Oh yeah, for sure. When it comes to OT, safety is a huge concern, and a lot of times we focus on manufacturing because there's safety aspects there. But you think of electric utilities and all of the concerns we have of losing our power. You think of water utilities where you can have a spike in chemicals that basically make that drinking water poisonous. There's so much damage that can be done if these networks are exploited. It's something that we're seeing in recent years is cyber warfare, and when countries do go to war, is how do we attack their critical infrastructure in a way that we can get an upper hand on them. There's so many industries that are at risk of being exploited, and they all follow the same frailties of not having security in there by design.
And Andrew, I guess another significant problem is that particularly in very distributed industrial control systems, let's think of the electricity grid or water supply or sewage processing plants and stuff like that. A lot of this infrastructure has actually been there for ages, for very many years, and it may have hardware devices that are 15, 20, 25, maybe even 30 years old. They have one particular purpose, which is perhaps I turn this valve on and I turn it off, and I do that very well and I do it with great safety. I guess the problem is that if there's all this, what you might call legacy stuff lying around that has just accumulated as we've put cyber mechanisms for controlling our physical world, it's very hard to find out where all of it is, because when it was put in place, there was not necessarily a reliable map kept of what went where. So how do you find out what you've got in an industrial control system before you think about how you're going to secure it? Because if you secure what you think you've got, you could miss some or all of the parts.
Yeah, it's one of the mistakes we tend to make whenever we try to protect the OT is sometimes we're too kind of standoffish into what is our responsibility and what is the responsibility of the OT. So we try to build this wall around OT and say we're just going to control what comes in and out of the boundaries that we control. What we need to start doing is really putting visibility deeper into the OT to truly understand what is actually down there, what is connected. And the only way to do that reliably is with kind of automated visibility tools of understanding, what is connected to my OT. There's been examples in the past where I've worked with customers and they've had a good working relationship with the OT team, but their visibility went as far as the firewall that they had in place. They've said this firewall is to protect you. If you need a port open or an application flow open, just reach out to us. We'll open it for you. It's not a problem. We just want to control the ins and outs. And to your point on regulation driving a lot of the security, one of the other things is actually insurance itself. In this case, they were trying to get insurance for their manufacturing site, and as part of that required a cybersecurity audit, because part of the premiums was, well, are you protected from cyber attack? And during this audit, they failed. I didn't know why they failed. They had to go and get a rundown of why. And it turns out the OT were daisy chaining all of the PLCs, bypassing the firewall. And the issue with that is it's because they had no visibility into what the OT was really doing. There's other examples that I show with Shodan being the search engine for all of the things connected to the internet. And there's a dedicated set of tools for looking at SCADA devices. Do you know if your devices have public IP addresses or not? You might think that they don't, but if you're not the one in control with them, how do you know what the engineers who put it in place did? So that's the kind of biggest concern I think we all have is just.
I guess the other problem with tools like Shodan and Census and things like that set out to map the internet is, firstly, they can be quite aggressive. I find huge amounts of entries in my own logs for the modest amount of server equipment I have at home, which are just those tools trying to find out what I've got exposed. So it's not only that they're aggressive, the whole idea is this becomes a matter of public record, doesn't it? So if you don't know what's there, cyber criminals on the other side of the world might do so, and they don't need any technical skills to do that. They just say, find me all the devices that are running this protocol that are visible on the internet last night. And bingo, in a few seconds, they'll know. So for attackers setting out and finding some potential targets, they don't really even need to do their own research, do they? They just look it up online.
Not at all. No, there's an example that I give in some of the Cisco Live sessions that I do, and I'm sure if listeners want to try it out now, it would probably still work today. You go to Shodan and search for a vendor called Unitronics. You will find devices out there that are still available on the public internet. And CISA has advisories for that vendor specifically because they were used in water and wastewater treatment facilities. And traditionally, well, not traditionally, but one of the deployment methods was basically putting them online for remote monitoring. So CISA put out this warning, basically urging people stop putting these devices out on the public internet. And the last time I ran it, there were still over 600 instances of Unitronics alone. And when I was running the presentation, I had some colleagues over in Italy, and I decided to mess with them because Shodan has a country filter. And I could see there were some examples that the VNC was completely open, no authentication. The web page was open, no authentication. It could have been a honeypot for all I know. I didn't want to click the buttons to find out, but the buttons were.
Yeah.
But that's the issue. To your point, there's no research involved. It's I want to attack a wastewater treatment. What's the prominent vendors there? Let me see if I can find one. Trying to find this country, let me go there. Shodan makes it so easy.
And the hard part is, some of those are, the utility is going to say, well, hey, let's use Texas as an example. Hey, we don't want to drive 3 hours to that, oil processing facility or, that mining facility. And so we need some remote mechanism, but everybody's afraid to put IT type security solutions in front of that OT device, right? So, hey, let's just make it easily accessible. And yeah, then you end up with this Shodan situation.
Yeah. Sometimes we look at IT as a bottleneck.
I guess another significant problem there is that what Shodan, Census, etc. can see is typically those parts of OT networks that are discoverable by conventional IT tools. In other words, let's do a port scan over IP on the internet. But if you are already on some, internet accessible device inside the OT network, the world isn't all IP and TCP and UDP and Ethernet packets, is it? There's a lot of historical baggage there. Some of it just because it's always been like that and it works. Some of it perhaps for regulatory reasons. So there are lots of different types of buses, lots of different types of protocols, lots of things that an IT person wouldn't know how to scan for, and maybe even for which reliable tools don't yet exist. So how do you take that into account, and how do you build that asset discovery inside a network where some of the parts may be using legacy protocols that really there aren't that many people left who remember, let alone have used professionally?
Yeah, so there's two ways to do visibility of these OT protocols. There's the passive way where we just kind of listen to what's happening, and then there's the active way where we get involved and we actually query those devices. And active does get a bad rep because we typically fall on words like port scan or network scanners that are traditional IT tools. And the reason they get a bad rap is if you do it incorrectly, you will or you may bring down OT devices because those legacy devices, they don't really handle a lot of that querying in that way very well. Might overload their CPUs, they're kind of small, and cause shutdown. We stay away from them. But active discovery for OT is a whole different kind of set of principles. It's you use the OT protocols themselves in order to do the discovery. So if you're a Rockwell shop, you'll use Ethernet IP discovery messages. If you're a Siemens shop, you'll use S7 or Profinet. Every vendor has their own communication stack, and we can leverage that stack in order to discover those protocols. So you basically investing in an active discovery tool, just make sure it's dedicated OT. Don't use IT tools for your OT processes. But that only tells you what exists.
Is that because by doing so, you're kind of, A, you won't find all of it, and B, it's a little bit like shoving knitting needles into holes and hoping the balloon behind does not burst?
Yeah, you don't really get a whole lot of information about what a device is just by knowing what ports are open. So as an example, Siemens, I'll take Siemens as the example. They have an application called TIA Portal. You use TIA Portal to program all of the logic on those devices. When you open TIA Portal, it does a discovery message. It looks for the Siemens PLCs in the network and gives you that inventory within the tool. We leverage the same mechanisms within our own discovery tools. So as a network security tool, we can do the active discovery using the same commands that say a TIA portal would give you. The thing though that we lose out on active discovery only though is you get an inventory. You know what exists on your network. You know the properties of that device. You don't necessarily know the behavior of that device. You don't know what it's doing on your network. That's where the passive discovery comes in. That's where listening to the traffic comes in. And that's one of the biggest challenges we have in OT is how do you get deep enough to actually listen to what these OT devices are doing? Because if you're doing passive discovery up at a core switch or somewhere too high in a manufacturing plant, you don't really see anything in the OT. So the biggest challenge we have is how do you get visibility deeper in that network?
Yeah, because as you think about some of these old PLCs may not even be on a network switch of any kind, right? Serial cables and other, connectors. So
Yes.
that I think makes it even harder, right? How for some of those,
HPIB, if anyone remembers that.
So security it's one of those things that we're just trying to manage and mitigate risk that we have. So yes, there's risk of devices being on a serial bus, but in order to exploit an asset that's using serial or on some sort of bus network is you have to be on the bus network. The reason why OT networks are being exploited is because those same legacy protocols that were once running on serial and now just running over IP. So you take something like a Modbus and there's no authentication on it. If I can reach a device over Modbus, I can tell it what to do. If I tell the PLC to shut down, it'll shut down. If I tell you to crank the temperature up to point of explosion, you're going to explode. There's no protections really in place unless you engineer the protections as part of the solution. So while yes, we still will struggle on things like our bus networks, making sure that we know every OT device that's on an IP network and understanding the behavior of that on its IP network, I think that gives us a great starting point to make sure that we're secure.
So what about devices? What about legacy devices of this sort? Perhaps ones that use a different protocol, a different networking scheme, or simply that have very, very little memory, very underpowered CPUs, and can't easily be modified or have their software altered to do all the latest and greatest security checks. How do you go about patching those devices in the way that we've got used to being able to do for things like laptops and servers on conventional networks, where we kind of assume, well, we've probably got at least half a gig of RAM spare if we really need it. We've got virtual memory, which can take some of the pressure off if we absolutely required. But for a lot of these, particularly legacy devices, even small changes can have a disastrous effect, particularly if they have some real-time component that requires them to respond reliably within a specific time. How do you deal with that in a world where we've come to expect devices to take patches readily, quickly, easily? You know, as Joe likes to say, with web apps, could be several times a day. How do you deal with that with a 25-year-old OT device?
Yeah, it's a difficult problem for sure. But when we look at why we patch vulnerabilities, is we're trying to again mitigate the risk that that thing could be exploited. So what we have to look at outside of patching is what are the other risk mitigation techniques that we can put in place. So let's
Right.
say a PLC has a vulnerability to its web server. Well, if you're not using the web server, just disable the web server. Then you can't exploit that vulnerability in the first place. So it's not patched. The firmware version it's running still has a web server exploit, but the web server was not running. Or you have a vulnerability that only happens if you're not in run mode of the PLC. Those are kind of very, say, easy ways in order to mitigate the risk is just disable the service in the first place. The other way then is just making sure that that exploit can't be accessed over the internet, or over a network, I should say. Let's say you have a an exploit that happens over a very specific port. Well, is that port being used? No. Well, can we then just disable anyone from communicating to this device over that network port? And if it is used, and it is used in a critical process, just make sure only the trusted assets can actually communicate over on those communication channels. The risk is still there, but it's massively reduced. What we see all too often in OT is because there's no controls in place and there's no segmentation. I just need to exploit one of your vulnerabilities, and then I can access everything. And if you're going to let me do something, you're just making it easy for me. We just need to make it difficult for the attackers.
Yeah, and that's something Andy Kling at Schneider Electric talks about in some of his public talks, is about how these devices don't have authentication on who's sending the messages and what the data is. So you might get a legitimate message from an illegitimate source, or somebody's in between where that message came from and they modified it. Uh, he's been on a quest for I don't know how many years now, trying to get device manufacturers to authenticate messages coming over Modbus, and it's just not picking up traction. And it's, on the one hand, it's understandable. These devices aren't patched a lot. They're not, they don't have a lot of extra compute cycles, but at the same time, like you said, once you're in, it's really easy to just send what you want, even if the device on the other end isn't expecting that from you.
Yeah,
Chen, I
the
guess
latest.
another problem with devices of that sort is that, particularly if the software that they're running was developed, say, a decade or more ago, you can understand why the developers would have focused on safety. Because they want to make sure that if a well-formed message is received, then it will be processed promptly and correctly. And that sort of took second place, if you like, to security, as you say, namely making sure that the legitimate message, well-formed message, actually was supposed to have been sent in the first place. I guess for programmers of limited power devices, it's reasonable to see why that would have been felt to be somebody else's problem. Their job is process the messages correctly. Somebody else's job is make sure that only legitimate messages get sent. But the world's not, unfortunately, not quite that simple, is it?
Nope, not at all.
So, what are some of the other things that can be done with these limited power devices, which, although you imagine maybe in 20 or 25 years' time, when we're at, series 73 of this podcast, maybe all of this will have gone away, and there'll be plenty of spare memory, and we'll even have EDR software that we can put on devices out in pump rooms. But for the foreseeable future, what can you do to increase the resilience of those devices without adding so much extra threat detection software or threat prevention software to them that they stop performing correctly? How can you build a sort of protection, self-protection into them without actually changing their behavior or their memory usage significantly?
Yeah, it's by basically not putting the onus on the endpoints themselves, but making sure that the network that they're connected to is protected. So one of the things that I think everyone in industry advocates for is the IEC 62443 zones and conduits model, and taking that approach of, rather than one large OT network, it's a lot of mini OT networks that you link together with conduit devices, switches, routers, firewalls, whatever it is that you're using to network between them. But the whole standard is all about breaking up that network into lots of mini networks and putting compensating controls between them. If you want to go from line 1 to line 2 or process A to process B, depending on the size of your zones, what are the permissions and what is the criteria for you to be allowed to traverse that? And what that does is just kind of limits the blast radius if an attack does happen. If there was some rogue backdoor that you didn't realize came into one of those machines that isn't really controlled by you, but the OEM that you bought it for, and they were to be exploited, well, at least it's contained to that one machine. They didn't have a path to jump through your entire network. Or if your IT was exploited, are you protected from them pivoting into your OT? And the network is the reason why we're vulnerable in the first place. And I think sometimes we overlook our responsibility to make sure that network is secure, not just functional.
So
Yeah,
there, I guess you're
from
alluding, Andrew, to the concept of segmentation, where you don't just have one big network where everything can see everything else, but you chop the network up into sections and you carefully control how those sections or segments can interact. So that sounds easy in theory, but in practice, even in IT networks where we've known how to do this for years, people often find it very difficult, not least because they start with good intentions and then find that they break things, and eventually all the doors they closed end up getting propped open again. How do you solve that problem in a much more variegated, perhaps much less well documented OT network if we can't even get it right in IT networks?
Well, I think that's part of the problem, and that was one of the questions you asked me when we first started. How did I get into the
It
OT?
is hard, and so it's just not easy. You mean?
Yeah, it's not easy, but it's also, if you think, you asked how I got into OT security, and the reason you asked that question is it's not everyone gets into the OT security space because it is very different than traditional IT security. So if
Yes.
you take a technology or a capability like segmentation, like we're already struggling with in IT, and then just try to apply it the same principles in the same way you're trying to do it in IT and do it in OT, well, you're going to fail even worse in OT because of how different it is. And one of the biggest mistakes that I see with segmentation of OT networks is not even a technology problem. It's not like we don't have the right tools to do it. It's the way we approach segmentation in this industry. So when we all moved to the zero trust model, where nothing can connect to my network until you verify the identity, that doesn't work in OT. The reason we've done it in IT is because I'm now working from Ireland. I'm going to be in Cisco Live in Vegas in a few weeks. I might be somewhere else in Europe a couple of weeks later. It doesn't matter where I am in the world. My identity and my privileges follow me and my identity. In an OT network, a production line doesn't work from a coffee shop from 1 week and then come back to the factory the next week. The physical
Yes.
location and the actual physical zone a device in matters. So I always pose this question: should the HMI in production line 1 control the PLCs in production line 2? And the answer is always no. So then why would we create segmentation based on device type? We can't say all HMIs have one relationship and all PLCs have another and all IO have another and this torque wrench does this
So the
every time.
HMI, that's the human machine interface. That's the device that has the buttons on it that somebody can press that actually say the valve should actuate, the welding machine should start or stop, the temperature should be
Yeah,
increased or decreased.
you need to
And
run this
somehow that
process.
has to get a message to the device that will respond to the button.
Exactly, yes. So, and it's purposely put in that area because it controls the function of that area. You take an automotive, you have a paint shop, you have a body shop, you have an assembly workshop, you have all of these different shops. they might be the exact same devices in them. They might all be using Rockwell automation. Or they might all be using, say, FANUC robot arms somewhere in their line. But it doesn't mean that all of these device types have the same privileges on the line. So when we talk about the zones and the conduits model, and we always go back to this, why it becomes such a relevant standard for us, is a zone can be a physical zone. So when you think of segmentation, think of the physical zones that you want to create. And oftentimes they actually align with your network zones. That you'll have separate VLANs for different shops with different VLANs for different lines. And there's normally a relationship between the networking and the physical zones. But that's the fundamental shift that sometimes we just need to go backwards with thinking a bit for OT. OT still runs legacy, so how would we have done segmentation in a legacy world? We would have done segmentation based on the office you're in or the location you're in. Just because it no longer works for IT doesn't mean we can't use it for OT, because a lot of the times it still works.
So how do you, when you try and divide up your network so that not everything can automatically see everything else, which clearly sounds as though it ought to be both safer and more secure, much, much less to go wrong, how do you, A, measure that you've done it well, so that you don't think, oh, well, I put in some firewalls, that should be enough, and B, how do you avoid being so zealous that you actually break something in a way that's hard to predict in advance?
Great question. Yeah, so when we talk about security, I always love bringing it back to the concept of risk, of managing risk. So there's three terms that I really like that I think grounds a lot of the security principles that we have. You have this concept of a risk assessment, and that's where the visibility comes in. That's why the title of this podcast is what it is because visibility is what informs your risk assessment. And your risk assessment is just tell me the threats, or let me understand the threats I currently have to my network and what would happen if those threats were to be exploited. And then you look at two very similar terms, but they're slightly different. Is you have risk tolerance, which is how much risk are you essentially willing to manage if something was to be exploited. So what is your downtime criteria? Are you okay with 24 hours of downtime, or can you only deal with 5 minutes of downtime? How much financial loss are you willing to accept? And what financial loss kind of does correlate with downtime? If a line is down for 1 hour, how much money are you going to lose? Various different incidents like that. Like what's a major incident, what's a minor incident? And you'll take that and you'll define, this is the amount of risk I'm willing to tolerate in my network. And the goal of cybersecurity, when you think of the North Star, when are we done? It's when the risk assessment aligns with your risk tolerances. I've assessed all of risk to my OT network. And if any one of these risks were to be exploited, because it always will be risk, there's no such thing as zero risk, then you're finished. Because you're basically saying, I'm willing to accept that if this machine was compromised, I would be back up and running, or that I've minimized my financial loss to the point that it's okay that it got exploited. That's never the case. So the last term then is risk acceptance, which is I'm willing to accept the level of risk because either I'm within my tolerances or that the mitigation is not cost effective. And risk acceptance is not a one-time thing, just like risk assessment is not a one-time thing. The level of risk I'm willing to accept today does not have to be the same as I'm willing to accept 12 months from now. And that's how I phase out my projects. So when it comes to security, it's really how much risk are you willing to accept? That's going to then determine everything. What's the size of your zone? Are you willing to let an entire production line go down in case of a breach, or do you have to limit it to a cell? Are you willing to let an entire building to go down, or an entire remote site to go down? That is what's going to determine how much effort you put in to your segmentation project.
So I guess you also have to be aware of the fact that there may be regulatory changes that come upon you that alter the risk acceptance algorithms, if you like, that you're allowed to use. In other words, it might become impossible to accept certain levels of risk in 2 years' time that may have been considered reasonable enough 2 years ago. Is that correct?
Well, a lot of these standards, they kind of give you your own kind of leeway into the size of the zone, or your own judgment into how you're going to go about security. What they're looking for, though, is that you're thinking about it, you document it, that these things are kind of auditable. The only real industry that we have is utility industry in the US, that NERC SIP. you have an electronic security perimeter, so they actually do define like what that perimeter is and what the criteria is for that. But in a manufacturing facility or these other verticals, the size of the zone is really up to you. And what they just want to see really is evidence that you're putting some level of compensating controls between them. But I don't foresee a regulatory body coming down and saying a zone has to be X size or this part of your network. I think they just want people to be doing something rather than what they're doing today, which is very, very little.
So, Andrew, as I think about risk tolerance and risk acceptance, one of the things that I've heard a lot from OT manufacturing and other kind of facilities is I don't know what all I have. Right. I think there was a really great talk at S4 in Miami back in 24, where Southern Company went to a small substation and said, "Hey, we don't even know what all devices we have in our substation." So, how do you think about risk tolerance and acceptance when there's some unknown amount of risk there that you can't even you can't put it in a zone because you may not be able to see it or know what it is.
Yeah, and I think that's why I said the risk acceptance isn't a static thing, and how it will change over time. So if you take a substation, you're accepting the risk that if that one substation goes down, I probably have to assume the entire substation is compromised. I'm not able to contain it into smaller zones. The substation is compromised, but how can I make sure that other substations or other parts of the grid are not affected by it? So that's where that electronic security perimeter comes in. I'm willing to accept that, I'm going to treat that substation as one single entity. It's either been compromised or not compromised. And that's the reason we also see NERC CIP bringing in new regulations around the visibility of within a substation. CIP 15, Internal Network Security Monitoring, INSM, is the acronym that they use, where they're now kind of mandating that you have visibility within that perimeter to understand if something is going wrong before it hits your actual perimeter device itself. Because for a long time, we accepted the risk that all kind of breaches would be contained within the perimeter. And now we've kind of changed that assessment to say, no, you need to now look further in. And it wouldn't surprise me if we see more and more tightening of those controls to divide your ESP into multiple zones. But we need to take the same logic in other verticals. So the worst scenario I've ever heard is after a Cisco Live presentation I did on segmentation, a customer came up to me and said that if they walked into any OT facility anywhere in the world, that they could reach any other OT facility anywhere in the world. They weren't even segmenting based on geo, never mind IT-OT boundaries. For them, their first step is making sure they have an IT-OT boundary. They have to accept the risk that their entire OT will be compromised, but it's a much further along than any OT facility in the world would compromise any other OT facility in the world. So everyone's on a different stage of their journey. You have to accept whatever risk you have now today and create a project that allows you to reduce your risk acceptance over time. Because if you take on too much from the start, we'll have the same conversation 4 years later and you won't have done anything.
Yes, it does seem that some of the biggest, if you like, industrial control incidents in history, and certainly in the UK where I live, the one that's now gone down as the worst ever is, of course, the Jaguar Land Rover outage, where their OT systems, their entire production line, as I understand it, essentially froze. And they couldn't restart it because they no longer had a record of which vehicles on the production line were at what state of production. And that didn't happen because of an OT vulnerability or an OT specific attack. It was actually a side effect of ransomware on the IT network. And therefore, something about that nexus of IT and OT was really the problem. In other words, that there was no part of the IT network that was invulnerable enough to a ransomware attack to allow the OT network to continue functioning at all. How do you avoid digging yourself a hole of that sort? Or
Yeah,
if you have one, climbing out of it, perhaps?
Yeah, like it's one of those things. If you look at a modern OT network now, it's hard to distinguish, well, what exactly is OT? Because we tend to think OT is as the PLCs and the control systems that we have on the production floor, but we're modernizing so much of our networks that we're relying more and more on virtual space and even SaaS applications. Virtual PLCs is now a thing where you can actually just run software to replace what that PLC was once doing for you. And it's really about understanding. Goes
So
back
that's
to
like a Game Boy emulator for a PLC that runs on on modern hardware. Have I
almost
understood that
you're just
correctly?
giving yourself the capability of being able to use modern software stacks in order to be able to control the inputs and outputs within a factory floor. Like we had a customer that they had 50,000 industrial PCs, and it's the same customers also looking at virtual PLCs, but just the PCs alone, they had 50,000 of them across their manufacturing footprint, and they spent millions of euros as a European customer to upgrade from Windows 7 to Windows 10. And then 6 months later, they upgraded, they announced Windows 11, and they said, "Well, we're not doing that again." So being able to take advantage, yeah, being able to take advantage of actual the all of the capability we have when we go to more virtual platforms, there's so much benefit to it, and people want to run it that way. And we underestimate just how much things outside of the control devices actually contribute to the OT itself. There was another example I have where the printers would have actually been a bottleneck for this OT, because at the end of the production line, after they went and shrink wrapped the pallet, they had to print the shipping label and where that pallet needed to go. And if those shipping labels don't get printed, that pallet stays at the end of the production line because they don't know where to put it. And they only have about 5 or 6 pallets worth of buffer room before they'd have to shut down a production line. So if you compromise the printer of that OT network now shuts down. And there's a lot of overlooked things that we have within our processes. And this customer specifically, when I was talking to them about it, they realized, well, their printers are on their IT network. So if they had to cut off their IT from their OT, well, that means no printers, that means production line shuts down. And that very simple attack that happened on IT, suddenly now OT is down. So yeah, it comes back to visibility again, but visibility isn't just what's on my production line. It's what is the behaviors, what's the relationships, what do my end-to-end processes look like, and
Yes, that word relationships, I think, is very, very important there, isn't it? Because you kind of think, hey, well, my production line's working fine, but imagine I actually can't move this stuff that's blocking up the exit to my factory because I can't print a single jolly label.
yes.
It seems crazy that you could fall into that, but it's easy why you would imagine that these are two separate problems if you haven't mapped that relationship out.
For
And I
sure.
think, Andrew, that's a really interesting point too, blurring the lines of IT and OT, right? Where most people think OT is just the PLCs, the HMIs, the servers, the servos, the motors, the robotic arms, but you know, a printer fits that. Or, if you've got a web server that's flashed up on a big monitor showing you your production lines and where things are moving or stopping, that's IT infrastructure. It's just sitting and showing you stuff on the OT side. And so, I think, we that's a very interesting thing where you can't just clean cut all the time between IT and OT, where, even if you're looking at OT security, you've got to have some thought for what are my IT assets that are inside that OT perimeter too.
Yeah.
Yeah, and that's even if they're in their perimeter, or whether or not you're just they stay on the IT perimeter. If you follow the typical Purdue model, sometimes these systems are in what they'd say the layer 4, layer 5, and that relationship goes across. So that the fail-safe plan of disconnecting the DMZ, well, is no longer a fail-safe because now you cause your own downtime. So yeah, unfortunately, there's no one size fits all when it comes to how we deal with this. It comes back to what I said before. You need the visibility to get started, and once you figure out what your unique challenges are, then you have to find a way to mitigate those challenges. And there's blueprints for it, but every customer is different.
So, Andrew and Shane, I'm conscious of time. So perhaps to finish up, I'll give either or both of you a chance to say something to people in organizations that have OT networks that maybe are thinking, I really need to take this whole cybersecurity measure and manage it thing more seriously, where would you advise someone to start? What are the first steps that, if you haven't taken any already?
Yeah, I can go first with that one. Visibility for me is always the first step. If you don't know what you
Yes.
don't know, it's hard to make that call. There's always things you can do without visibility, of course. You can create bigger barriers and bigger points of control. But just saying that, I have visibility to a certain point on my network, that's good enough, and you try to wipe your hands of the responsibility, sooner or later that's gonna bite you. Um, really get in and understand your OT processes. That's, with tools that help you do that, but also build that relationship with the OT team, figure out what the dependencies are, where the parts that can really cause your downtime are, and help OT, with their day-to-day job, because they will put things in like remote access tools without letting you know unless you do it for them securely. So you just need to get involved with the OT teams, make sure that you are there working with them, helping them, and IT doesn't feel like a bottleneck for that team. It should be a collaborative process.
Yeah, I mean,
Okay.
I think Andrew covered that super well. Visibility is key. I think I'll maybe take it the step further of, I think you need a physical asset inventory, but also a digital software asset inventory too, right? Um, in maybe a great way, a lot of OT ICS devices have a much longer support tail. So, it's not like your mobile phone that maybe stops getting updates after 2, 3 years. There's bound to be updates available for a lot of these older devices. And EU CRA is even pushing some of that support lifecycle even further. And so, knowing what you physically have is great. Being able to box that in and create those zones and segment properly is good, but also getting a good digital inventory so that you can, plan out patches, and work through, with the actual team that's running that manufacturing floor or those OT, like when can we turn this off to actually do an update and, start to get a plan together. And if you can't, that gets back to Andrew's, points about accepting risk, and maybe you put some extra security controls around that to try and detect issues with those devices that you can't patch just yet.
So to finish up, it sounds as though that old maxim in the IT world that if you can't measure it, you can't manage it, is extended in the IT world by the fact that if you don't know it's there in the first place, if it's not visible, then you can't measure it. And so you certainly can't manage it. So the first step is find out what you have, both physical and in a digital, from a digital point of view, the software bill of materials, etc. So, gentlemen, thank you so much for that. It's clear that this is a very difficult problem to solve because there are so many moving and static parts, and because the world is under so much pressure to automate and improve services. So, thanks for your thoughts on how people can actually make a good start to making sure that they're not just in OT, but they are in cybersecurity as well. So that is a wrap for this episode of Exploited: The Cyber Truth. If you enjoy this podcast and find it useful, please don't forget to subscribe so you know when each new episode drops. Please like and share us on social media, and please leave us a review if you can on your favorite podcast feed. That really helps us get the message out to the community that this sort of information is available. So thanks to everybody who tuned in and listened. And remember, stay ahead of the threat. See you next time.